Hi, I'm Emanuelle Frery from CSIRO, which is the Australian Science Research Institute. And today I would like to speak about hydrogen exploration at Rift and Rift in Margin. And I'm going to focus this talk on an Australian example of hydrogen leakage at the surface. So this work has been done with my colleague, Laurent Langui and Médéric Mason, and in collaboration with Isabelle Moretti from Pau University in France. Before starting, I would like to begin by acknowledging the Whadjuk people of the Noongar Nation as the traditional owners of the land from where I presented today, and I would like to pay my respect to their elders, past and present. My research work is focused on the study of circulation of fluid or gas along fault and the evolution of this circulation with time and space in a given geological setting. Well, my understanding is that most of you have a geodynamic or tectonic background. So before going in more details, I will try to provide some context on the recent tectonic evolution of Australia. On this slide, you can see 3 extracts of the global plate motion model published by Jurassic in 2016. It's going from late Jurassic to present day. You can see that the present day tectonic configuration of Australia is the result of long-lived Indo-Australian, Eurasian, and Pacific convergence accommodated by the subduction of the Tethyan ocean system. In Australia, we are starting to find occurrences of natural hydrogen, including hydrogen from abiotic sources in numerical geological settings. On this map that has been published just a few months ago by Geoscience Australia, you can see where we find natural hydrogen, and in red, in the red spots, you can see that some of those occurrences are pretty high, more than 10 mole per percent of the gas. And you see that these places are located in very different geological settings, like the Yorke Peninsula or the Ilgan Craton in Western Australia, or even in a basin, in different basins on the east coast. Well, if you are, because you are not familiar with the geology of Australia, I can just add this map that have been published recently by Jurassic in 2019, and this landscape reconstruction is using the Badlands code, which have been developed by Kristen Sell, and I think it well illustrates the location of the craton and the basin at mid Cretaceous, so you can have a better idea of how it was in the past and why you've got those different places in Australia. I found it pretty handy. So my work is really targeted on the exploration of hydrogen seeps in Australia. And we initiated a project a few months ago, so it's really new, where we tried to understand the hydrogen system with a focus on the seeps. Here at the center, you can see how we articulate our work. So we're going from a literature review to the review of the different types of physical imaging we've got in Australia. Here we have to know that in Australia, we've got a lot of data which is available, and this is thanks to the work of the Geological Surveys and the Geoscience Australia that put all those data in the public domain. And then we target some zone of interest. We've been in the field to explore those targets, and now we're doing some monitoring. And all that is to try to understand the hydrogen system, either if we've got a system which is like a petroleum system with a source, a migration pathway, and a reservoir, or is something more dynamic with like a perpetual source, as you can observe in geysers. Well, in different places of the world, like in the United States, Russia, Brazil, or Mali, people have observed circular to elongated surface features that have been proved to be emitting natural hydrogen. And in Australia, we've got a lot of features that are similar to that. And if you ask a local what they think about that, they're going to tell you, well, that's a Salt Lake, mate. The good thing is, like in the last year, there were some desktop studies that have been published, and that saw that looking at the different statistics and the shape of the feature, it's very likely that they are hydrogen emitting feature. So our first work was to go in the field and test if we really find hydrogen in this type of surface feature. And to do that, we decided to go in our backyard. So today I'm speaking from Perth, which is located in Western Australia, and this city is located in the Perth basin. So here we are on the east coast of Australia, and we've been looking at circular features like that are really similar to the one we observed in Brazil. And all those features are located along a fault, which is called the Darling Fault, and which is a major crustal boundary, which is separating the Hy-NAT craton towards the east and the Perth basin towards the west. And we've been working in this area, well, because it's handy, it's really close by where our lab is located, but also because it's an area which is explored for oil and gas industry. So you've got a fair good amount of geophysical images and as well as seismic and well data. So first, we've been looking into the geology, and here in blue, you can see the area with high density of potential Ferry cycle, of potential surface seep of hydrogen. And you can see that they are mainly located along the trace of the Darling Fault, which is, as I told you, separating the craton, where we've got a lot of mafic dike and plutonic rocks, as well as ultramafic rocks that can be source for hydrogen. And also, in the Perth basin, we can see that there are some places where we've got also high density of potential Ferry cycle. And you can see here the well, which is called Yalali 1. And I will show you later that this area is a crater impact where you can have some potential connection from the depth to the surface. And I also add the location of recent earthquake. As you can have in mind that this area is tectonic, is active with even if it's low magnitude, you've got some seismic activity. So here is the magnetic image where you can see really the difference of signature between the soft sediments of the Perth basin towards the west and the mafic and ultramafic rocks of the Hy-NAT craton towards the east of the Darling Fault, which is in dashed line still. And you can also better see the crater impact I was speaking about. We also reinterpret the seismic line there, and here is an example. And what we saw is that some of those most of those potential Ferry cycle are located on secondary faults that are breaching on the Darling Fault, which is here in dashed line. So we are in a structurally complex edge of the basin. Following the desktop study, we've been in the field with a GA5000, and we measure the hydrogen. So on this aerial picture, you can see potential Ferry cycle. Well, no, we know that is a Ferry cycle because we've been measuring hydrogen and we found some. And you can see in blue the area where we find hydrogen. So it's mainly located around the external edge of this circular feature. And I like to show this example because it's the first Ferry cycle we've been looking at. And at that time, our sampling method wasn't the best. And the maximum value of hydrogen we were finding were 96 ppm. And believe me, it's not a lot. It shows you that you really have hydrogen above the atmospheric background. And we also did some tests to make sure that we didn't artificially create that hydrogen, but still, it's not a lot. But I can tell you that since we did this work, we improved our sampling method, and we've been in other parts of the basin, and we find value above 200 ppm. So we are sure we find hydrogen. So on this slide, I tried to summarize all the different hypotheses we've got on the hydrogen system from our initial observation. So you see in orange and red the plutonic, igneous, and ultramafic rocks of the Ilgan cratons that are separating from the Perth basin by the Darling Fault. And you can see that those rocks in red are also below the Perth basin. And this is because the Perth basin has been created on the top of the Pinjara orogenies, which during the separation of Australia and India. And to make things simple, you can have in head that the rocks that are in red are potential sources for hydrogen, as they can generate this gas from processes of deep hydration or radiolysis. And we observe that the Frery cycles, so here the cycles that are in green, are located mainly along the fault. And we think, like as I told you, this area is active, is seismically active, that some events such as earthquake can open the fault. So you can have some triggers that can open the fault and initiate the migration of hydrogen along the fault. And also, you must know that in the Perth basin, we've got a lot of low salinity aquifers. And this it has been shown in recent studies that if you have low salinity aquifer, you can also dissolve and transport hydrogen, dissolve in water. So that could be also another system to look at. So to conclude, there are really a lot of options to explain the hydrogen system in the Perth basin. All we can say at the moment is that there is a link with the fault system. It's something we can see, but we cannot exactly explain what is the origin of this hydrogen and what is the frequency of circulation and the duration. And we are working on that. So we are now initiating the result I present you today have just been accepted in the International Journal of Hydrogen. So if you want to know more, this article is going to be really soon available. And now we are doing we are starting our monitoring phase with better analysis of the gas, and yeah, this is a phase which is going to take more time and which will give us more clues on how works this system. Thank you for listening, and I'm going to be here to reply to your questions.
Okay, thank you, Emanuelle, for sending us that, and I hope you are around to answer some questions. Can you let me know if you're available?
Yes,
there you are.
Sorry.
Brilliant. So if you have a question, again, you can type it in the chat and I can read it out, but otherwise you can ask Emanuelle yourself. So I see Herbert has a question. And Frida has a question as well. Should I read one of them? Let me scroll back. Is it?
No, I can just
okay.
say the others were answers to other previous questions. I was just wondering, because it seems to be that the Perth Basin is quite faulted, and I was just wondering, if there's any active faulting going on, and if there could be some mechanoradical hydrogen formation, as has been shown to occur at the San Andreas Fault, for example.
Yeah, it's active, but it's not as active as the St. Andreas. It's really a microseismic activity. But to tell you the truth, we don't know much about the source of hydrogen. So now we are in the phase of just analyzing the sample in the lab. And it's so there, we started with the Perth Basin because it's really local, but it's not the place where we find the highest quantity of hydrogen. In those areas we have, because if you want to do isotopy, and if you need quite a lot of hydrogen, so if you just have few ppm, you're not going to go far with that part of the work. But there are other places with much more hydrogen, and so it's really starting. I think like in a few months or in a year we will be able to share more results.
Yeah, exciting. Thank you.
I also see a question in the chat from Jean-Baptiste. To know if he wants to ask. Or should I read it? They ask any insights on the origin and source of natural hydrogen in the Amadeus Basin.
All I know is, and I think Eric as well saw this presentation, is the one of that Santos did at the Hy-NAT conference, and they were thinking it was more like radiolysis about for the source. This kind of process, but I never saw a sample from there.
Okay, yeah, keep an eye on the chat. There may be more questions popping up, so if you could answer those, that would be great. And thanks again.